Okay, welcome to the notes of conditions of triangle similarity. It is the third lesson in this unit. So first we have some vocabulary to talk about. The word dilation is the word dilation means a shape that has the same angles as a different shape, but proportionally bigger or smaller sides. So like, let's say I have a circle and then I have another one that's twice as big, or 3 times as big, or half as big. Those are all dilations of each other, because the angles of a circle are all the same always, and they just get bigger and smaller. So if you look like here, these two shapes are dilations of each other, because they're the exact same shape. It's just that this one's bigger. And bigger to a proportional amount. So remember, the word proportional means that it all gets multiplied by the same number. So something that's twice as big would all get multiplied by 2. Or something 3 times as big would all get multiplied by 3. So if you look at this one here, 8 times 3 is 24. 6 times 3 is 18. So this shape is 3 times as big as this shape. So the number you're timesing by for that proportion is called your scale factor. Right? So the scale factor is the number you're timesing by. I'm going to actually write multiplying by for the dilation. Okay. So two shapes are similar, so the next word is similarity, and two shapes are similar if they have a dilation. So two shapes are similar if they have a dilation. Meaning all of the sides are proportional by the same scale factor. Like if they're all being times by 2, or all being times by 3. And that the angles are staying the same. And that matters, that the angles are the exact same. So remember, congruent was the symbol for it was the equal sign with the tilde above it. The symbol for similar is just that tilde. So not the equal sign, because they're not the exact same, but they're similar. So that's what the little tilde means. Okay, so moving into this C example, right? Comparing the heights, they said the bigger one was 24 and the smaller one was 8. So if you do 24 divided by 8, that ends up being 3. Meaning to get from the original to the new one, we multiplied by 3. So when you're trying to figure out how you get from here to here, if you don't know that 8 times 3 is 24, you could always figure out by doing the 24, the second one, divided by the first one, like they showed here. Or you could have done it here by doing the 18, the second one, divided by the first one, the original being 6. And 18 divided by 6 is also 3. So that's how you can figure out that the scale factor for this guy is 3. So, here, if you come down here, it says, what's the value of x is a? Well, first of all, I have to figure out how I even got from 6 to 72. So if you don't know, if you do 72 divided by 6, you would get out 12. So to go from 6 to 72, you ended up multiplying by 12. So to go from 8 to x, you end up doing 8 times that 12, because that was your scale factor. And 8 times 12 is 96. So x would be 96. Then it says, Casey wanted to make a reduced C to wear on the necklace. She's decided that she would like the height of this C to be 2. Okay? Well, for this one, the original on all of these was the height was 8. Okay, so on the original, so I'm going to redraw the original, and the height's 8. And she wants her new one, her height, to be 2. Well, to go from 8 to 2, what do you times by? If you don't know, you can do 2, the second one, divided by 8, the first one, and you get 0.25. So to go from here to here, you times by 0.25, because that's the scale factor. So to get this guy, because the question is, oh, it just actually says what should the scale factor be, and so the answer is 0.25 for the scale factor. However, if you wanted to figure out that x, you would do 6 times 0.25 to get that x. And finally, it says what would happen to if the scale factor between two of the c's was 1? And the answer is it's the same shape. Because when you multiply anything by 1, it's the same thing. I'm going to go ahead and flip it over now. We're going to go up to this picture, and it asks us, are these two triangles similar? Well, right now, remember for triangles to be similar, all 3 angles have to be the same. That's first. And they all are. See, 1, 2, 3. They're all the same. And then all of the sides have to have a scale factor that makes them the same. Okay? So, to go from 15 to 6, and I know these are the same because it's between the right angle and the 2 ticks. So right angle and the 2 ticks. So these are the two that are supposed to be dilations of each other. So if I don't know how to go from 15 to 6, I can figure it out by doing 6 divided by 15, the second one divided by the first one. And if I do 6 divided by 15, I get 0.4. So my scale factor is 0.4. Then, to get to 20 to 8, I do in my calculator 20 times 0.4, and it is 8. So far for these two, the scale factors are good. But I don't know about this third side because I don't know what either of them are. But if you remember Pythagorean's theorem, this only works for right triangles. And these are both right triangles. And it says a squared plus b squared equals c squared. Remember, c is the hypotenuse, which is across from 90 degrees. So this is c on this one, and this is also c on this one, because it's right across from 90 degrees. And so with the formula, a squared plus b squared equals c squared. 15 squared is 225, because 15 times 15 is 225. 20 squared is 20 times 20, which is 400. And when I add them, I get 625, which is c squared. So that means some number times itself is 625. And the answer is 25. Is times 25 is 625, so just c, not being squared, is 25. So this guy's here is 25. And if I do it for this one, I have 6 squared plus a squared equals c squared, because my two a and b are 6 and 8. 6 times 6 is 36. 8 times 8 is 64. 36 plus 64 is 100. So 100 is c squared. So c has to be some number that when squared it's 100, and the answer to that is 10. So this c is 10. So I need to check, is 25 times 0.4 10? And if I put it in my calculator, yes it is. So these two triangles are similar. Yes, they are. Okay? However, you don't have to know all 6 things in order to know they're similar. Just like with conditional, or not conditional, just like with congruent triangles, there's certain theorems that we know make triangles be similar always. Like always, always. And so there's 3 and there's three, that if you know two angles are the same, you actually know the two triangles are similar, no matter what. So as long as the two angles, and these angles have to be congruent, the exact same, then the triangles are similar. Also, if you have all three sides being multiplied by the scale factor, the same scale factor. So remember, parenthesis means multiply. So if I have all three sides being multiplied by the scale factor, the same scale factor, then the triangles, no matter what, are going to be similar, because it's going to actually force the angles to be the same as well. And then finally, if you have a side being times by the scale factor, and then two angles that are the same, and then two sides that are just the same as long as they're being multiplied by the scale factor, then it also forces the two triangles to be similar. And so all three of those are enough information to let you prove that two triangles are similar.